Okay, hot take. I think as human beings, we take our hands for granted. We're easily able to navigate 3D worlds. My hands can pick up objects effortlessly. Opposable thumb, these digits can manipulate objects, no problem. But what happens if I have to do the same thing with, let's say, a robot arm? Being able to feel how much force I'm applying, get that force feedback. That's where a robot arm, whether that's operating in an industrial environment where humans are not supposed to be due to hazardous conditions, or a robot arm is performing a surgery, or in maritime underwater applications to collect samples, do repairs. How do you control that? A mouse is not adequate. It can only see in 2 dimensions. It was designed for a 2D world. For a 3D world, you need something like a haptic device. And I'm talking to co-founder of such a device, Happily Robotics, my next guest, the amazing Colin Gallagher. I want to get into how he got into haptics, what are the applications of it, why he believes that the time for haptics is now. He's making waves, partnering with NVIDIA, getting accolades at CES. And beyond just robotics, there's the concept of 3D worlds, being able to create and navigate and train in 3 dimensions is applicable to gaming, in entertainment, movie industry, anywhere where you're creating a virtual environment, a haptic device comes in handy. So it's a very exciting and interesting space with lots of applications. I am very excited to be talking to Colin. Come along with me. Let's add that 3rd dimension to our perspective and dive into the world of haptics. My name is Ali Afzal. This is Robot Builders Club. Let's go. All right, Mr. Colin. Finally, being able to have you on the podcast. It's a pleasure. How are you feeling?
I'm feeling good. Thank you. Thank you for rescheduling from last week. I appreciate that.
Yeah, no worries at all. A pleasure's all mine. Nice to have you. So just to tell our viewers a little bit about Happily and the space you operate in, you're making intuitive input devices for robot control, simulation, for navigating 3D worlds. I saw really cool clips that I'll embed into this for training applications. So it's a very cool space. You've said haptics could become on your website as important as the mouse or the touch screen. That's a really bold statement. Why do you believe that? Let's start off with that.
Sure. So one of my favorite YouTube videos you can go watch, it's called like The Mother of All Demos. And this is from like 1958 out of Stanford, where they introduced the computer mouse. And the idea is that it was this really funny interface where they were kind of not sure what it was going to necessarily be used for, right? But they had built this HMI, so human machine interface, this input device, basically saying, we don't love like the keyboard and terminal, it has limitations. The punch cards, they have limitations, right? We need a way to lower the barrier of entry for people to be able to start interacting with different types of computer applications. And one of my favorite lines from that demo, they do like 4 or 5 things in the show about it, but they say, and this is we call this the mouse. We don't know why we call it the mouse, but it probably won't stick. We'll come up with something else. But then like that's obviously now we look at it. What is that, like 70 years later, 60 years later, and it's stuck. But the concept is that what we build is effectively a computer mouse, but it is one that allows you to interact with things in 3D and to feel what you're interacting with. And there's a couple different interfaces for it. A lot of times this digital sense of touch, they call it haptics, and it can be done either through like the vibrations on your phone is a type of haptics. What we focus on is what they call force feedback. It's not a particularly new technology. It's just like you need a lot of convergent things to evolve in order for it to have different market appeal, right? Like even you look at the first, like I think it was for what EV vehicle like GM came out with in like the early 90s, but you need battery technology, you need everything to kind of evolve. And now we have EVs. And so the premise is now we're starting to see new applications emerge that are going to be some of the most important applications that are going to touch humanity, no pun intended. But these concepts of things like, industrial robotics, robots that are going to be humanoids, they're going to be in the streets, in the factories, in the stores, and fulfillment centers, everything. And so having a way to interact and naturally control objects in 3D, I think is going to become incredibly important. And there's no real way to generate forces. So forces, one of our thesis is like the sense of touch is very important for a lot of the really precise things that we do when we're manipulating the physical world and objects and things like this. So when we say that haptics is going to be very important, and these devices can become very important, is that they're going to be very transformative for the way we collect data and train machines how to interact with the physical world.
Yeah. And I think that's where the name comes from for your company, right? Haptics, happily.
Yeah, you got it.
Were you also thinking of happiness by any chance?
Yeah, like, so it's a fun, obviously, like a little overloaded, right? Like happily, and it comes up in puns all the time. Like we have happily anniversaries for happily birthdays for our employees, and the people that work on our team, and it always comes up like, I'll happily do that for you. But there is a funny story about that where it's actually, her name is Morgan Thiel, and if she ever listens, it would be funny if she did. But she was one of the first, like, we did an accelerator program, and she was basically like the first like intern that we ever worked with at Happily when we were like 4 people in a room, right?
Okay.
And she came up with the name, she came up with the logo,
Oh, wow.
she came up with the color scheme. So I owe Morgan a lot, but it's funny because it's a great name. So
Yeah, we'll tag her. Well,
yeah, exactly.
yeah. That's very nice. That's beautiful. And I see a lot of poetic touches when I was researching your company and the way you guys operate that I found fascinating in stark contrast to the way robotics companies are typically laid out. I think the maturity of your company probably also has something to do with it. But in particular, I saw you said, we envision technology that should speak in the warm, familiar cadences of human touch rather than the cold, alien tongues of machine. That is a very philosophical, punchy piece for a hardware company. How does that philosophy of warmth and human touch, and keeping in mind that technology is typically oftentimes machines, we think of them as cold. How does that translate to your product decisions and how you're building your company?
So I won't take credit for that exact line. I'm sure it was built off of a lot of, maybe I'll give credit to either the marketing department or maybe it was a LLM or something that's a machine
Take
that generated
credit.
that beautiful flowery language.
I wanted to hear it was all me.
No. So what I will say though is maybe to take some credit is I think what we build. We talked about the applications in robotics, but there's also applications in things like 3D design and modeling and CAD, and that's actually where the origin of a lot of our version of the technology comes from. So to just take a little detour, is like the technology has been around for a number of years, but in its original form, they used to have things called I think they're pantographs and things like this that they could use to move around, and they would manipulate, like architects and stuff would use them for drawings to be able to duplicate. And then that evolved into handling of basically fissile and nuclear material and stuff like this when you had to be away. And they had these beautiful systems and machines that used to do it almost all mechanically. No, it was all
using levers, essentially.
Yeah, levers and cables and things like this. And it was actually in the mid 90s where a guy who's actually very pertinent right now, because he just was unseated from his place in the Senate. It was Thomas Massey, who was one of the senators from Kentucky, and he was just basically unseated like in an election 2 days ago or something. But he was at MIT, and he actually invented the version of our technology, which was kind of the desktop haptic device, which was, hey, let me see if I can create a virtual world. And then instead of it being real forces that I'm interacting with, like when handling nuclear material or stuff, it was actually interacting with a digital version with a force physics engine and stuff like that. And so he invented this with a professor, his name was Ken Salisbury, and this was at MIT. And they created a company called Sensible Technologies. And that company ended up building this great device. When I say display, I mean like the same way we're looking at a computer monitor that's displaying to our eyes. This displays touch to your hands, like these forces. So Ken and Thomas created the company. And Ken is a very close advisor of mine. He's been my kind of one of the academic idols that I've had for a very long time. And I see him, like, he's at Stanford now. He moved from MIT to Stanford. But every time I go to the West Coast, I'll kind of hang out with them. And they're very different characters. Thomas Massey he's a conservative senator. He he was kind of not anti, but he kind of went up against Donald Trump recently. And that was kind of why they had some basically falling out that led to him being basically losing his seat. he's had notoriously, pictures over the years of like a Christmas photo of him like having like a bunch of guns with his family and things like this. And so Ken is like a blue haired, like has ponytail, does this type of things.
Okay.
But they both created this company. I just find this super fascinating that, that personality, like technology isn't bounded by these like personalities or archetypes or whatever sometimes.
Yeah.
But so they created the technology, and then they actually, because they were in search of an application, they built a 3D modeling software that eventually became called Freeform. And
I've heard of it.
and this is like 3D modeling and sculpting, and you can feel what you're interacting with and doing that type of stuff. So the notion of the creative soul of this type of technology comes from a very beginning, like early on. And I like that it walks, like you have these companies like NVIDIA that create, on one hand, games, on the other hand, robots, on the other hand, like these 3D worlds like Omniverse and stuff like this. And I like that they walk that line between creativity and kind of like, and deep tech, enterprise technology, like advanced stuff. And there's a soul to it. And before starting the company, I was part of like some 3D, or like, let's call them like digital art collectives and things like that. So I think the UX and always appealing to an audience, making that like wow moment where the people will try your technology and their eyes will light up because it's like, oh my God, what the heck? I just felt a thing from a digital world, and it is the most rewarding experience. And so there's a humanity to it. And I think it being a human machine interface, so that HMI, even that sounds like there's a human, like that intersection between human and machine is incredibly, incredibly important. And a lot of the best things that we use and interact with as just like interfaces, the best ones are ones that are easy, are intuitive. We can interpret them. They're predictable. We understand them. And that communication piece can go so many different ways beyond just sight and sound. And now we're dealing with touch with our devices. So it ends up being a very important part. And so the UX is I'm obsessed with the user experience design.
Beautifully explained. I love that how you laid out, once you are interfacing with a haptic device, it's a completely different experience for those that have not gone through it. I'm at Johnson & Johnson MedTech, and we have a haptic device on the surgeon side, right? So it's, once you've used it, it feels almost as an extension of your arm. It doesn't take long for you to feel as if the robot arm that you're controlling using the haptic device with the forces, you neurally link yourself almost that way. But I want to unpack the technology a little bit for those, a lot of folks out there that have never used a haptic controller or even heard of a haptic controller. Could you give a quick 30-second version of what does it feel like to use? And you touched upon why it matters because of the applications and how it opens up these 3D worlds and how you can manipulate objects. But what does it feel like, and what does the future hold? What's the impact and sort of the future of this technology?
Okay, so I know you're at J&J. I'll try and be, we'll talk about the competitor for 1 second. This whole the application of this technology really saw its first kind of massive moment with the rise of surgical robotics. So, the company Intuitive Surgical, they have about a $200 billion market cap, and they build a robot that is so easy to use that a surgeon who knows nothing about quaternions or Euler angles or, singularities or any of these roboticsy things, they're not a robotics integrator. They can sit down and they can do very, very complicated stuff. They can suture, they can cut, they can drill, they can, flay open material and do this kind of stuff, right? And the ability to do that type of manipulation is so easy that they named this $200 billion company Intuitive, right?
Yeah.
So the concept of humans being able to manipulate things in D is so innate to us. We go back literally millions of years before we were humans. We were called the genus human. Before that, we were like, the ancestor was called Australopithecus. And it's the first evidence of they walked up on two legs, but they were about maybe 3.5 feet tall, and they were preyed on by lions, and they were walking out on the savannah. They were just very unprotected, but there was the first evidence of them actually like napping stone tools and making like sharp points and actually fighting. There's evidence of them fighting off some of these like predators, right? And so it kind of happened as a let's say accident in evolution that we were swinging through trees. So we had these graspers, and then all of a sudden we stood up and we freed up these hands, and it's like, what do we do with these things now? Right? There's lots of like animals that walk on two legs, but we're the only ones that had these like really this ability to do dexterous things. And so we started making tools, hunting, fishing, making fire, doing all this kind of stuff. And then as a result of that, our brains grew. So our ability to use tools is so innately well understood that when you are doing things like surgery and things like this, and you're starting to leverage these like haptic interfaces, they allow you to naturally move in the motions that we know how to do, right? We're not using a computer mouse. We're actually able to feel the interactions and do this stuff. So it makes us a lot more precise, a lot better at what we do. And so the core aspect of the technology, what we try to do is say, hey, this Intuitive Surgical is a $200 billion company. What happens for intuitive non-surgical? So what about all these different domains where we can use this type of intuition, but apply it to industrial robotics, apply it to 3D like design and art and this stuff. But it has a very different unit economics. So you have to really try and drive for accessibility, a price point, orders of magnitude lower than what would exist in the willingness to pay for a hospital or something like that, and target different volumes. And so at the end of the day, I kind of described what we did, or at the very beginning, I should say, as a 3D mouse. And that's all it is. It's like, you know how you use a computer mouse to point to objects and click? We're just pointing and clicking, but letting you do it in 3D. And then the sense of touch is very important for the surfaces that you interact with, because it allows for insane levels of precision that you can't get if you're just moving your hands in another open kind of air.
Yeah. So, in terms of commercial, industrial applications, that total makes sense. You'll use it to move robot arms, whether that's in a factory or a surgeon is using a haptic device to feel the feedback and do the procedure. What about the consumer side of things? Is it trying to understand, is it just around artistic expression? Is it gaming, navigating 3D worlds, sort of like the metaverse piece? What does the future hold? Will I have, as a regular consumer, a need for a haptic device anytime soon?
So the way that we're trying to approach it in the context where we're first trying to appeal to what they call like prosumers in that space, to really gauge the interest test the waters in areas like 3D modeling and Blender and Freeform and Maya, and plugging into game engines like Unity and Unreal Engine, because there's productivity gains to be had there, which are like, okay, it's really easy to set up a 3D level and to move a part around and to draw a path for your characters to move along, or rig up a character. It's very easy to do that with the right 3D interface, right?
Cool. Yeah.
And so we're trying to target that, but we envision a scenario where when people who are the professionals get this and start being able to use this, and the value proposition is there, and that it's a nice, elegant systems to use, you can understand it, it's predictable. There's been no system like this that has really tried to emphasize like usability above really understanding that the difference between lab equipment and a consumer product is really that, right? It's like, it needs to work where somebody can just walk up to it, throw out the instructions and like figure it out, right? And so that level of communication for a new interface that can apply forces and wiggle and move around the table and stuff like that, you have a whole different type of design language. So we are first testing it in these productivity spaces, but with the intention that this goes into areas like, we can see it going into areas like gaming, where I'm playing Dota or I'm casting a spell and it locks me in place for the 3 to 5 seconds, or there's a bomb that goes off or a spell goes off and forces me like across the screen, or inverts the directions that I'm moving in XYZ kind of thing. And so we do see that there could be a lot larger mass market opportunities, but we're really focused on the productivity prosumer side right now. And as one application, and basically robotics data collection and policy training as the other. Those are really the two areas that we're focused. And the reason why I say that it is focus is that anything that these markets in 3D modeling and design already exist. These products already exist. They've existed for a long time. Now we don't rely on this technological readiness of like humanoids or robotics at a whole to be viable tomorrow in order for our company to be viable. But we're setting ourselves up with the most elegant user experience and workflows so that people who, if it works in 3D modeling and design, it's going to work for people when they sit down and they're a warehouse operator and they know nothing about robotics and they can just plug in a device and use it to control one of the fleet of 30 or 50 different types of robots that might be in their warehouse.
Yeah, there's so many applications, right? It's just at the end of the day, it's a smart input device. So we are interacting already with different environments, virtual and non-virtual, and we're trying to manipulate objects. And this is a more advanced tool in that sense. So where do you see the biggest growth taking place? Like you have all these verticals. What is the future from your perspective of haptic devices? Where you touched upon the 3D model gaming side of things and robotics training, all of that. Where is it headed in the short term versus sort of long term?
So I was trying to kind of allude to the idea that in the short term, we're just focused on the UX, and that already will satisfy. It's the lowest hanging fruit for us to basically work. Was one of a partner that we work with is called Hexagon. We announced a partnership with them last CES. At CES, we actually won 2 Best Innovation Awards, which was one was in robotics and for our robotics data acquisition tool, and the other was in 3D design, right? So very like these very different kind of conceptually different areas, but it's just the same. It's the interface, the way that the human can describe motion. And so where I basically think that the area I'm most personally excited about is the idea of, and again, it's always bridging these 2 areas. I call it kind of Warcraft for warehouses, right? It's this idea that the last 30 years, you saw all these, basically a whole generation of people, of gamers trained on how to control fleets of units in StarCraft and Warcraft and move them around a map and have them do different tasks and manage them as this very like supervisory role. And so I see this concept in the robotic space of us trying to build the workflows that will facilitate very similar workflows to how we all use ChatGPT and Claude and any LLM today. Is an idea, we spit an idea, we have an idea, we build a context for it. It might be from our speech to text or via keyboard, which are these human machine interfaces for that. And then we plug it into a model and it basically spits out something and we evaluate, we iterate upon it and decide, is that good or is it bad? Is it not good enough? And then we go back and we refine it with our own insights, right? And eventually we spits out an artifact and we're like, good, that's great. But this is this concept that language is like used in LLMs, but motion is also language, right? It's describing when you're trying to tokenize the next syllable with an LLM, you're predicting what the most likely next action would be. And then there's some magic to that. But then when we're trying to do the same thing, but for motion and robots and how they interact with the physical world and do all this kind of stuff, it's about building that workflow. And what that workflow requires is a really precise way that's low barrier of entry, easy to use, that can basically describe motion, right? And we don't have a way to do that. There's like virtually no other easy way to do this because getting really good position data is hard. Understanding the forces from the environment is hard. And so we just happen to have this interface that really has been proven out in the surgical domain that we're trying to now apply it in this other domain and say, hey, let's be part of like that core part of that workflow, which is the iteration, the input, the context generation, and then the refining. And we've done some really cool stuff in this space. Maybe I can share some videos with you that might
that would illustrate. Well. You have a lot of cool videos on your website too, which gets the point across. Yeah, embedding it would make it real for those that are able to watch it. So what you're referring to is the training problem, right? Being able to train on whether it's within robotic arm or some other application in physical AI, training the motion of the device. How big of a bottleneck is that right now, being able to teach the physical AI?
I think it's a massive bottleneck. And like, that's why these companies, like whether you have certain companies like Amazon and stuff, who are investors in our company, but they also put a lot of effort into like, okay, there's approach like omni retargeting, right? Like, so trying to get videos and retarget positions and map them to the robots and things like this. So just watching you do the task. Then there's other things like there's what they call like puppets or kinematic puppets, which like are, if I had a specific robot and wanted to collect training data, I would have a little mini version of that robot that would like be in front of me that I'm controlling, and it's the same structural kind of lengths as the big one. So then I'm able to do the actions and use that as data to collect. And so the problems, some of the scalabilities and bottlenecks here are pure quantity. Like, so just being able to like get enough people to even have access to these tools. So that means they have to be scalable, they have to be accessible, they have to be robust, they have to be like to meet the needs of people doing data collection and stuff and training. So you need that to happen. So there's price point constraints there. There's even the idea that the internet has been around since like the mid 90s, early 90s, and it's been like at least late 90s in its current form. And since then, we've had lots of Reddit posts that we could, train these LLMs off of, but we don't have anything like that for motion. So the bottleneck of data is going to be a big thing. But companies like NVIDIA and stuff are really saying, hey, like, let's leverage reinforcement learning. Let's leverage simulation in order to be able to generate like lots of synthetic data to train these policies. And I think that's a really interesting thing. But it's kind of like if ChatGPT trained itself on only ChatGPT output, right? And you started from the very beginning of the internet using something like that. So what we're trying to do is say, hey, you can have both, providing the appropriate number of like you train a foundational model, which is like your ChatGPT or whatever, off of all this source of data. So you have companies like Physical Intelligence, and Groot is a NVIDIA model, and Robo, and which is Hugging Face. They build these models of like demonstration data and stuff like that. That's equivalent of your Claude. And then what happens is you still want to refine that, right? And that's where the imitation learning
the real
comes
world
in.
data.
Exactly. And so that's where the imitation learning comes in, and demonstrating it and then seeing what it outputs in simulation. Does that look right? Does it look like it hallucinated a little bit? Oh, let me just select just this time series. So it ends up like some of the software that we're working on looks like Windows Movie Maker, right? Like you edit the time series you want. You can play back just that segment of the train policy. Then you can go in and say, oh, no, actually, I want you to go ahead and move this screw from here to here, and then do this. And you demo that about 4 or 5 times through our device. And then that then refines the policy so that it's overfit just for that like little segment. And it's much easier to do that for a small segment than like a much larger approach. So the workflows are everything. And that's really what we're trying to say, hey, let's build the first workflows that make sense with this. And we just happen to have this device that has proven itself to be really good for really dexterous type of tasks from surgery and stuff.
Yeah. So these companies such as Rhoda AI and I believe Skilled AI is also trying to train robots on YouTube data and
Yep.
the data that you mentioned, I forgot the term you used, that is out there in all these different environments. That is going to create a foundational sort of basic 1.0 model, allow physical AI to be real world ready. You still need the actual human input, and haptic device such as yours bridges that gap. Is that the right? Did I understand that correctly?
Yeah, I think you understand that correctly. Like we have a superpower, right? We're the only animals that build these tools and interact with the physical world and shape like, the environments around us, and all kind of stems from our ability to manipulate things. So like, I really like your analogy, and I'm going to use it, is like, yeah, this is a ChatGPT 1.0, right? When did it come out? What 3.5 came out and people were like, whoa. And then 4.0 came out and people were like, okay, this is a real tool that I can actually use in my work, right? And so the idea is that prior to that, there's lots of like, that human in the loop was really important. And this is after 10, 15 years of generating, 20 years of generating data through the internet, right?
Yeah.
And now we have beautiful ways of, how long was it until we got really good, like, let's say, speech to text translations? Now they're great, but like that's relatively new, right? And so now
I remember early 2000, Dragon Naturally Speaking was the breakthrough. I remember trying to write an essay by speech, and it was very buggy, and I gave up. Yeah, so it's pretty early on. Yeah.
But you could imagine like now we can just transcribe every Netflix show, every
Yeah.
YouTube video, and you generate
It's
lots of other
seamless.
synthetic data. Yeah. So that's all. It's not synthetic, but it's generated in a different capacity. And so I think like lots of the video stuff is very cool. I think they're inevitably, even in the best case scenario, we're never going. The reason why like our type of devices have even niche beyond just like the first. I'll take a step back here in a second, but like we have some applications where we can control resistors on a PC, a micro, like circuit board and stuff that are like a few hundred microns, right? Tiny little like 01005 resistors and things like that. I'm talking, they look smaller than a grain of sand, right? And you can go in with tweezers and manipulate these things. And it's very important for things like optoelectronics. And then you have things at really big scales, like cranes and manipulating collecting this type of data at really remote places, doing it in like mine shafts, in these type of things. So I envision that a lot of even the teleoperation data and the basically the real world applications of these and us aggregating this is going to be a really long tail. Like we're going to require these in it's going to scale where it's going to be like first one device to like maybe 2 haptic devices to 10 robots, then 2 to 100, but now I'm going to have 150 times more robots, right? So the number of units I think is going to go up a lot. And then there's going to be a really long tail where even look at like Roombas, for example. A lot of people have robot vacuums, but they still get stuck on cables. They're still doing all like these type of things. And it's like, we can just go back in when they get stuck and pick them up and go place them back on their charging port. But that's not so easy to do with a robot that's in a mine,
Right. Heavy
50
equipment.
miles away, or a robot that's across the factory doing something. So there's going to be a lot of different areas. And then I like to basically say that what we're building is like just the steering wheel for basically a more complicated motion than just on a road.
That clarifies a lot of things that I had questions around. Thank you for illustrating that sort of the future vision that you have. In my mind, as I was looking into haptics and trying to make sense of the future, it to me, in the beginning, it felt like as we get more autonomous, which is the holy grail that everybody's going after, autonomous systems, something such as haptics is not going to be needed. But that is not the case. You're saying your premise is that human in the loop will always be needed, even if you have full autonomy, because there will be edge cases of trying to service a robot or trying to rescue it.
Or teach it. Like, let's say it's out doing something and it runs into like I use this as an example. Like I live in Montreal, which is a lot of like staircases and old buildings and these type of things. And
European.
Exactly. My robot walks up my Amazon delivery robot walks up the stairs, and then it's confronted with a doorknob from like 1850. Right? Like even humans, with all of our knowledge, I remember having my university roommate. He lives in London, and trying to unlock one of his doors was just. I still can't do it, and he makes fun of me. They gotta like lift up and click the knob and like do this, and so those are those type of things where like people, we always need intervention when it comes to like how to do certain tasks and these type of things. The benefit of robots is that we'll be able to like kind of have that, maybe that Neo moment in the Matrix where like, I know Kung Fu, and it's that kind of concept where we can then spread the knowledge instantaneously or over a night. They come back in overnight, upload their back into the command center, plug in, upload their own experiences and egocentric views, and maybe a human had to step in and intervene, and through that process, now they can upload that in as a new source of data for the next model to be trained. A month or two, the next version of the model comes out, and they now have all the new sensory information. So I think the scale is really going to be important. But we're talking about something like the physical world and all the complications of like different materials and hardnesses and these type of things. Very hard to simulate, to just get in all of this stuff from simulation data. And so I think with the scaling and the success of humanoids and robots of different types, that's going to allow us to start collecting more and more data of the physical world. But I mean, this is not something novel. We've seen this happen with Waymo and autonomous vehicles and stuff. They've been driving around on streets for years with drivers and collecting data and doing this kind of stuff. And that's a much more constrained problem than just like open world physics and assembly and all the different products and things that exist.
Yeah. What's the toughest piece of product development for you? What are the constraints? Is it on the hardware space? Is it business development? Where are the challenges?
I would say yes. I would say like there's challenges in a lot of different areas. I would say that from my perspective, I am my background. Did mechanical engineering at McGill University, and then I did a master's in kind of robotics and applied mathematics. Then I did another. I worked for the Canadian government in neurosurgical robotic haptic stuff, and then after that I worked in computer science. I did another computer science graduate degree, and so the idea is that I am very much a like kind of technologist at heart. So my answer might not be, it's going to be more about like trying to build like a really good interface that I care that the product itself is really good and brings joy and does that. One of the issues that there's regression as you start building the product and doing this and implementing things like, oh, I thought we whacked that mole like, a year and a half
Solve that
ago,
problem.
and now it's popped up. Yeah. And so, this is a lot of like I think our company's around 50 people, 51 people right now. So we're hiring a bunch more. And the idea is that with that scale comes like a lot of more process oriented stuff and making sure that we retain the level of quality that I want to be proud of, right? I want to be proud of the company. You live one life as far as I can tell, and you want to build and put something out there that you yourself are proud of.
Right.
And so that kind of, I think, what's the push and pull of like, oh, I got to go sell this and tell people that it's going to do this and talk about the vision. And then meanwhile, it's like, okay, but let's just make sure that the product itself is a nice experience and it behaves in a really predictable and elegant way. And so, yeah, I would say that I personally think that what I want to focus on more than what I personally care about is making a really great user experience.
Yeah. And what you were talking to, any scaling company goes through that. When you're a handful of people, the communication between departments, it's just individuals is seamless. You're sitting around in one office, and I don't know who coined that, but it's a law of X. Like once you go from 1 to 10, from 10 to 100, you have to rethink your ways of working. You have to reorganize your processes, break down, and same thing happens from 100 to 1,000. You have to completely rethink how you lay out. That's the business, company, organizational side of things, which makes sense. You're scaling. I was also interested in terms of your devices that you're building, Inverse and Harp, and what are some of the technical challenges? You're building an actual hardware product. Is it sourcing? Is it manufacturability? Is it integration? What are you seeing that would be indicative of for somebody that is trying to build a haptic device or something in the same space is going to go through, that they could listen to this and go, okay, this is what's coming my way.
Yeah. So I'm very lucky. Like I have two co-founders, and Felix and Steve. And Steve is, I have been working with Steve for we met in our master's degrees and playing board games. And I really needed somebody to help me build the electronics because, you hit a boundary where you say, okay, I don't know what I'm doing here. So I was able to get his help after a lot of convincing. I'm very fortunate between Felix and Steve. And Felix's background is more mechanical design, and his dad has a machine shop, and he's been building things since he was like 10. So when you ask me about the manufacturing stuff, I don't want to be the one that oversimplifies, because there's lots of problems there that they fortunately kind of shield me from having to deal with. Now, from my perspective, I think one of the hardest parts is again around like user experience, which is you have an entirely new interface. And what I mean by that is you have in a computer mouse, you have like left click, right click, scroll wheel. Maybe you can click the scroll wheel, and then you have a XY position on the mouse, right? when we're starting to get into spatial motion, so 3D motion, and when I say 3D, I really mean 6D. And for like, the audience will probably get it, but that sounds very abstract to some people where it's like translations, XYZ, but then I can also rotate around the 3 axes, right?
Yeah.
And so we're doing this 6 degree of freedom motion, which you have that, but then you also add forces to it, right? So now I can output forces and maybe
In
torques
all
and things
those
like this.
dimensions.
So and then you have buttons and things like this. So I'm trying to create this user experience that kind of expands what the traditional mouse is capable of doing, but now it adds forces. So what does it mean to snap to a vertex in a 3D model? Is that the right UX? Well, we got to build this whole UX. We got to understand like, okay, I'm moving, I'm grabbing onto a part and I'm dragging it across. I'm changing the scale of it. Do I feel little ticks every like step of the way? Cause so building those like UXs feels a little bit at times just like, it's very artisanal. And
Yeah.
so that's very challenging. And then from the more of a physics-based kind of side is with a mouse and most of these things, like you're not actually ever injecting energy into this system. And I know that sounds kind of abstract, but what I mean by that is like, I can push on the mouse. The mouse does not
Give a
create
force feedback.
push back on me usually. And so what that means is basically we are afraid of sometimes getting in the let's call it workspace of like a giant industrial robot arm because it can hurt you, right? And what that means is at this scale, it can still start to do things. It can't hurt you. It's like a small amount of force, maybe a couple pounds, but it can start shaking and doing things that if like it's kind of like a it can be, if it's unpredictable, the user loses trust. And the minute the user feels dumb, like they can't figure out the interface, or they lose trust because they feel like, am I breaking it? Am I doing something wrong? Or is it gonna hurt me? Or is it gonna knock my water off the table or on the table or onto my computer, my laptop? So those are those type of things that you have to start to account for too, where you start to build in safety features and things like that. Really, like if the user doesn't ever realize they're there, you've done a good job, right? But otherwise, if they don't, we've had users that over the years, people tried the devices out and there's different things. They start shaking or they start, a device just, moves on its own across the table. People look at it like all of a sudden it's an unknown to them, and that's what you want to avoid. So I would say it's an interface device, it's an input device. So you need to make the user really comfortable. That's the most important part.
That makes a lot of sense. And thank you for putting it so eloquently, right? It comes down to trust, because at the end of the day, the product that somebody is trying to deploy and get adoption for needs to be seen as trustworthy, needs to be seen as usable. And you are the gatekeeper as the interface company, as something that's enabling the connection between the human and the machine. If your interface doesn't work the way, it doesn't establish the trust and doesn't establish intuitiveness, then adoption has failed.
Totally.
The product has failed. Do you have competition in the space? I know nothing about haptic devices out there.
Yeah, there's a few great companies. There is a company in Switzerland. They're called Force Dimension. They do they're on the International Space Station. They do some great manipulation of more like medical scenarios. They're like a kind of a higher margin, lower volume play, if you will, than what we're trying to. We want to appeal to a larger audience. There's a company called Haptic. They're based in Laval in France, northern France. Their niche has been historically in like the handling of in like nuclear facilities. They came out of the French Atomic Energy Agency.
Makes sense. Yeah, that's big over there. France has a long tradition of nuclear innovation.
And then like from a competitor perspective, like there's, philosophically, you're also competing with other entities like what is like for data collection, let's say like a haptic glove or we talked about this, like just recording and playing back hand gestures and things like this. You're competing with like legacy kind of, not, I won't call them legacy, but other modes of input devices. Like there's a 3D mouse called the 3D Connection Space Mouse, and that's used for 3D CAD and stuff like this, but it has limitations that it's really about just like kind of push on something and I can it's kind of like flying a plane or something. I can change the velocity by pushing on it. I can't actually directly manipulate, but the whole ethos is that people are trying to find good ways of interacting. For us, the legacy, the like kind of historical incumbent was the device called came out of, mentioned Ken and Thomas Massey earlier, or Ken Salisbury, Thomas Massey, where they basically, their company got acquired by a company called Geomagic. It got acquired again by a company called 3D Systems. And then they separated between Hexagon and 3D Systems about the IP. And so they have a haptic device that came originally from the 1995 version that Ken and Thomas had built. So like I said, the technology is not necessarily new, but it's about novel paradigms about how you approach it. And what I mean by that is you have a bunch of convergent technologies, like Unity, for example, is a gaming engine that wasn't even developed until around 2008. And so you look at that wasn't even available for them when they started the company and doing this stuff. And so there are things like that, which are like the convergent technological readiness. There's
cross-pollination of tech and different applications coming together.
And then even the concept, like when they started, like the paradigms were different, where it's like you had desktops, you had these type of things. Portability was not a constraint. So for our product, the value propositions have really been around, like, we want it to be performant. So it's really, really good. We have sensors that I think should make their way onto almost every single robot, even not haptic robots. We just, we fell on to basically building these and designing them and inventing aspects where it was a constraint of haptics has to go really fast. So if we're looking at like a computer screen right now, it's updating around 60, maybe 144 hertz times a second. As in haptics, it's the standard rate is around 1,000 hertz. We can drive it up to several thousand hertz, 8,000 hertz, this type of thing, right? And so what that does is it leads to some kind of, I won't get too much into the kind of quanta and time, like sampling problems, but you get a lot of noise with sensors. And so we had to build a really high resolution sensors in order to run really fast control loops. And so the sensors we actually have designed and patented are around over 1,000, like sometimes almost like they're around 24 bits, which is around 11 million pulses per revolution, which allows us to get really good haptic feedback. They're very, very sensitive, and we can output the velocities like thousands of times like faster than what's normal. But the reason what this does, it gives you really good performance. So we care about performance is what I'm trying to get at. But performance isn't enough, because you put like an interface that's not portable on a table when you give to somebody in today's day and age where they have laptops, they go to the coffee shop, they're working from home, maybe they're going into the office once a week. You need an interface that allows them to basically move that from all around. So we developed a lot of stuff around portability, having different attachments that we can use gloves, we can use VR controllers, we can attach our own styluses and handles. So building those interfaces was important. And I think one of my favorite design paradigms that we did over the last couple of years and won the CES Best Innovation Award for was taking one of these devices and making it so, I'll just tilt the screen down for a second, that you could have the haptic device and use it on the table like a traditional 2D mouse. It was backwards compatible with all the software out there and recognized like a computer mouse. But when I lifted it up off the table, now all of a sudden it became this 3D interface, and I could go ahead and start interacting with 3D software. And so that really is like bridging that gap, making it backwards compatible, trying to make it so that it was usable.
Yeah. Which device is that?
That is the Minverse. The Minverse is the version like I hold very near and dear to my heart, because that's the kind of interface that I always wanted. One of the North Stars we say as a company is we want a device so easy a 5-year-old could use it. Yeah. And the concept is just, I have a couple nephews and my mother, and I remember I like putting these devices in front of my nephews and letting them play mini games. We build like mazes and stuff within the company. And I want to just like, the Minverse is the one that I'm like, okay, I could see my nephew who's 7 sitting on the lap of my grandmother and playing like a puzzle game or something where they're moving blocks and doing these things. And it's just like, the gaming side of that is so like, it's so accessible and real because of touch. That was something that I really like that device for those reasons. I think that's the one that can bridge that.
Once you're done with the pro users and all these applications, sounds like you're thinking of a future where you're going to be a gaming company
Mhm.
with me and regular people using your devices in the gaming world?
I think that there's I do believe that it will head there, and like the ability to have modular systems where it's like have a really nice haptic 2D mouse. Like Razer has a nice scroll wheel mouse. You have like different, like maybe force inputs on the surface of the mouse. There's really nice sensor, like skin sensors and stuff now. But then when I need to, I can just clip it in, and now it becomes part of this like interface. And so building more of a platform that enables this like diverse interaction is what I'm interested in. And then when the gaming side is when we started the company, we literally were going and talking to like the McGraw Hills and the Thomson Reuters and saying, hey, this could be used. You can teach kids how to dissect an amoeba, like abstract concepts like that.
Yeah.
They can learn physics by like, I remember one of my favorite demos. I did a NSF project with UBC, and my co-supervisor was the one who had the project. She was from Stanford. They basically, we did a student design. It was part of like, it was the Haptic Co-Chair Challenge in like 2017. We did this design challenge, and that was kind of when we started the company, because people at the afterwards were like, hey, can we buy these devices? Because we built these things, and it was the hardest I've ever worked in my life. It was like 4 months of like going from a demo at a conference that had won like one of the best demo finalists to like a product we shipped to 35 people, and they built demos on, and we had physics engines and 100
Yeah.
pages plus of documentation. There was no Claude at the time. And but my favorite demo was one where they built bridges. It was a team from Turkey, and they built like these trusses, and you could like pick a point, pick another point. You felt like the thing, and then you loaded the bridge. You know that classic game where like you make like bridges out of spaghetti straws and stuff?
Yeah,
You were
yeah.
doing this, but you were
What
loading
load
it
can
with,
they take?
yeah, you were driving a car across it. And then you could push down and you would see the deflection, and you'd feel the deflection and this stuff. So I loved that stuff of just like trying to get people engaged through
Yeah.
different,
So that's when you were trying to find product market fit. You're saying, right? Like you're going
oh yeah.
at the teaching environment, and I think you were headed towards like the gaming side. And I wonder, being in Montreal, having Ubisoft, and that probably was helpful too, to have access to those companies.
Massively so. I mean, we bootstrapped the company for the first 5 years because nobody wanted to give a few $1 million to a couple of grad students kind of thing. And so,
Right. Yeah.
so we bootstrapped it, and the company's 8 years old now. And so we basically, the first couple of years we got really lucky because we were in Montreal. It was after that NSF project. I came back to Montreal. I had this existential drive. We finished, I was in Vancouver at the time, and then I drove down and had my first like kind of Burning Man experience. I was listening to Zen and the Art of Motorcycle Maintenance on podcast about quality and these type of things. And I was like, what the heck am I going to do after this? Maybe I apply to some PhDs or whatever. And then people started making these orders. So me and my co-founder, Eve, were like, let's just build a website. And it said Haptics in Montreal, showed a couple things. And then we got contacted by some of these game studios that were working on location-based virtual reality at the time. Like we had like, Mark Hamill playing with some of our VR swords and things like that. And
Wow.
it was really cool. But it wasn't surgical robotics or anything, but it was still like paid the bills. And then we worked on that from like late 2017 to, or like 2018 to like 20, and then location-based virtual reality in the span of 1 month disappeared. When COVID happened and nobody was going into arcades, and so we had to figure out what to do, and that eventually got us back into the Haptic 3D system. We were always working on it, but we were like, okay, this is time to do this.
Yeah, that's an interesting journey. The great thing about you guys is you were paying attention more than just being academics, right? Masters and mechanical engineering. You're open to the signals that your Montreal local environment and globally is giving you for the applications, and capitalizing on that Montreal ecosystem of gaming, which is what the successful founders need to do to find product market fit. Look at what's happening in the environment locally, and more than that, what other use cases are out there that you can capture a market share in, that you have access to.
So can I ask, like you, I know we've spoken before this, and you're originally from Toronto, so you're also Canadian, but you moved, you're now in San Jose. So you're in the
Bay Area,
South
yeah,
Bay
San
Area.
Jose.
And so one of my favorite kind of quotes that I had heard from his name is Helge Seetsen, and he started a company, and he exited his company. I can't remember the name, but now has a company called Tandem Launch, and it's kind of an accelerator. They incubate companies, more of like an incubator. And I listened to him talk at a event maybe 6 months ago, and he said, "Oh, one of the biggest issues we have in Canada, kind of on the East Coast and that place outside of the Bay, is that there's too much of a gap." He goes, the Venn diagram between nerds and people who have money is too far. Whereas in the Bay Area, you start getting a lot more of that people that just get excited by technology, and people that want to like build things, and the attitude is way more like less risk averse, I guess. And so, do you find a difference? You now living in San Jose, what would you say, being on that side, is the biggest difference between your experience there versus here?
I think Bay Area, I'm a big fan, right? So take what I say with a grain of salt. It's a special place for innovators, for people that are trying to start things, not just in robotics, for any space, because there's this trifecta. You got academics, engineers, they're there bringing the talent, thoughts. Then you have an ecosystem of industry. All of the large players and anybody who wants to start a company has some sort of presence here. You're opening an office in Bay Area too, right? And then the third piece is that investor piece that I think you were talking about, which is the biggest differentiator. You have smart people everywhere. You have companies everywhere. It's also the capital is there, the backers of the ideas.
Mm-hmm.
They're all co-located within 30 minutes drive, 30 to 45 minutes drive, which makes this space like unlike any other. You have that model being repeated elsewhere in the world, and even in the United States. You got the Silicon Alley and Silicon Slopes in Utah. And
my favorite line is from The Simpsons, and it actually makes fun of McGill, which is my alma mater. But it's Marge is talking to Lisa, and Lisa doesn't get into Harvard, and Marge says, "Lisa, you can still go to McGill. It's the Harvard of Canada." And then Lisa looks at Marge and goes, "Mom, anything that is the something of something isn't really much of anything, is it?"
Yeah, I think it's changing. There's democratizing of talent, and we've also lost some of the magic in the Bay Area with Meta and a lot of these ultra dogmatic founders, that softness, that let's do something good for humanity, that is taking a back seat, at least in the popular culture, in terms of the loudest voices that are out there. So we're going through a transition period too, where people are trying to, there's a fight for the soul of Silicon Valley and what innovation holds here. But having said that, truly a special place for all of those reasons that we talked about. Where can I buy your device? Where can I test it out? Do you guys have it available?
Yeah, we have them available. The Minverse had a Kickstarter campaign, and we have we basically we iterated upon it, and the UX is, like I said, very much something like you really realize when you're designing a product that's going into, let's say, it's going to be shipping tens of thousands of them, and you want to make sure it's robust and very user friendly, and is going to require less support as a result. You really want to make sure you dial that in. And I'm going to be honest, we probably bit off a lot by having multiple products super early on and doing this stuff. But the flip side of that is through the whether it's the CES wins and these type of things. Like, I'm not going to say that we might not be here had we taken a different approach, right? So I'm not going to say it. It's just a lot of work, and so the Minverse, I would say, it's like we are shipping it. We've shipped it to most of the distributors. We have about 100 plus distributors that we're dealing with, and we've been shipping them over the last few months to really start doing onboarding, training the platform, setting up the bundles and things like this. And the goal is that they should be available for a wider purchase very, very soon. And we just really want to make sure we lock in the integrations with the supported software that we're partnering with, because the point is, we're not trying to sell something that's going to go just have a novelty factor and sit on your desk. We want to sell a real tool, right? And so it's a lot of work, and you can buy the inverses and stuff. We've been selling them for the last 3 years. So contact through our sales department, and those are around 5,500, but they're targeted very much towards the
Pro users.
industrial robotics and stuff like that. But the Minverse we're targeting for around $1,500 and bundled with some software that has like has basically software costs that are very much in line with what users who work in the 3D modeling and design space are accustomed to. But my whole goal is, if I can have it my way, is to really drive this the price point down to the point that we can get it so that people can use the system and we can monetize things through tokens of how long they're training the robots for, how they're doing this type of stuff, and trying to figure out ways to really lower the barrier of entry for people to have access to these tools, because I think that that's one of the biggest barriers eventually we were talking about of this whole ecosystem succeeding is how can we build more, how can we aggregate more data, how can we start to describe motion more effectively, how can we start to do this stuff. So
yeah, a few comments from my side. I love your commercialization strategy, that early access program, the vision that you're laying out. It makes a lot of sense. It's very impressive. Like you're a young guy, but you've I think you've got a handle on how to think about it in terms of a longer strategy. You're thinking the long game, starting with the pro users, and more than that. The other thing I was going to say was the industrial design of the product itself is sharp. Looking at the videos, I would try to embed it. That looks as if it's a product coming out of Apple or some of these really, really high end type of hardware mature companies that have experts working on the different aspects of industrial design and mechanical design, all of that. So yeah,
I'll relay that to Felix, one of my co-founders, and like our team is around 50 people. Like I was saying, it's like, and we're generating like substantial revenue. We've 10x'd our revenue in the last couple of years. It's like it's a real company. It's I would say like the investors won't like this if they see this, but like I think what motivates me a lot more is the legacy. In the concept of, like we talked about it, you live one life, and it's like, okay, I want to try and build something that brings, like, that can help shape some aspect of the world or humanity or tech or progress. And so I do want to really make sure that the user experience is good, because that's the only way it's going to succeed.
Yeah.
Yeah.
No, beautiful. I'm also flattering you a little bit, keeping in mind that maybe you'll send a device my way.
Absolutely. No, absolutely. I think we talked about that. We'll get you a Minverse. What color do you like? What's your favorite color?
I'm joking.
I know, but I'm not. What's your favorite color? Red. We'll get you a red. Nice, very fast Minverse. I like it.
That's awesome. Wonderful. What I was going to say was the office that you're opening up in the Bay Area. What is the
intention
piece? Yeah. Why now? What exactly is the function? What will it be achieving?
So we participated in a couple. So we have some investors in the Bay Area, like Draper and Associates, Plug and Play, a few entities out there, and it's been really amazing to see how many more introductions and things like kind of propagate out of. So the capital the capital markets, or exposure to like the ecosystem there from a VC perspective, it's like you said, like nothing else. I've spent time in New York City. I've spent time in our lead investors from our last round are SM Ventures. They're from Atlanta. I do have more kind of, historically, I've been more on the East Coast, but the idea of the US and Canada, but the idea is that on the West Coast, my family lives in California, which is a nice thing. So they live in San Diego. And so there is, on one side of it is selfish. Like I like being out there so that I can take a 1 hour flight down and then spend the weekend with my family and my nephews. But the other side of that is like you mentioned it, like everybody's within 30-minute drive of each other, right? So you can go see at the same time Physical Intelligence, Intuitive Surgical, Figure AI, Autodesk, all these different entities and companies, NVIDIA, like we work a lot with NVIDIA. And so the goal is that I see the way that the kind of, let's call it like the future, the sci-fi or whatever, feels like it's written in the Bay Area, and then the world kind of follows on, and that's where I feel like having access to those markets, but also there's great talent there, a lot of like really great UX developers and things like that. The concentration is very high because they can work at 30 different of these companies that have like hundreds of $1 billion plus market caps. There's a lot of there's great cross pollination. There's some downsides to that, which is like, you
lose talent easily.
You lose like everybody I talk to is like expect to have somebody like a year or two maybe, and then like and that's not everybody, but it's very much a thing. And you as a startup are going to be competing against I've gone down, and it's so funny. Like I've gone down, and my mentor Ken has introduced me to some of his students and been like, maybe you can work with them. And they're like, yeah, I have offers from 7 different companies and blah, 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 and these some things. And you go, it's so funny because that ecosystem doesn't exist here, but there's good things about here too, right? Like in Montreal, you talked about the gaming community. We have probably one of the highest per capita, like number of universities, I would bet, in North America, if not like the world. There's like six or seven like kind of universities in Montreal, which is 4.5 million people.
I did not know that.
Yeah. And so that's great. And there's also strong cultural ties and stuff here to Quebec, and which will kind of, I think, builds a stronger kind of, we can build. It's not uncommon for us to have people work with us for 2, 3, 4 years, even coming out of university, or
more tightly knit. Yeah.
So there's that thing. But to answer your question, long story short, is there's capital market side. There's the exposure to like kind of, I think, people who have good tech talent. But the most important thing from my perspective is Canada and Montreal and Toronto and these other, but Canada at large does not have, I think, the business development talent. We have really smart people. We can build cool technologies, but the idea of like commercialization, we don't build a lot of billion-dollar private companies or unicorns, what they call them, or you don't have, like, I always use Seattle versus Montreal as an example. They're both roughly 4.5 million people, but in Seattle you have Amazon, Microsoft, Starbucks, Costco, Boeing. I'm probably missing like a massive company. Like those market caps are huge. That even is much smaller than San Francisco, for example. But in Montreal, it's orders of magnitude, probably like, one order of like 10 times fewer the growth, like the market caps of the companies or things like that. I'm very interested in going there to be a part of that ecosystem, making sure that we can set up showrooms, talk to lots of the clients, make sure that we're part of that scene. We can build better relationships with the companies that are raising hundreds of millions of dollars. Hopefully we become a company that's raising hundreds of millions of dollars as we go along that trajectory.
That makes a lot of sense. Thank you for laying it out. That ties in that whole journey and how you're approaching, how you're seeing the market and how you're seeing Bay Area. There are insights in there for folks that may be considering having presence in the Bay Area, right? So it validates the capital markets piece and the talent piece. Gives me good insight too, and to others. Thank you for being so generous with your time and talking about it freely. It's wonderful connecting with you. Before I let you go, I know you have a busy schedule. I want to extract.
Time flew. I see it's hour 16.
Yeah, it's almost.
Thank you.
We're at top of the hour. So before I let you go, I want to pull more information from you through this lightning round tradition that I have on Robot Builders Club.
All right.
I'm going to throw a whole bunch of questions at you really, really fast and rely on your first instinct. Don't think too much about the investors and your customers. We'll try make sure we're not scandalizing you too much. Are you ready? All right. One robotic company that you admire.
Intuitive Surgical.
That makes a lot of sense.
J&J.
No, I think Intuitive Surgical for sure. Yeah. But yeah, J&J has its own. They're my employer. So. One sci-fi interface that inspired you.
I love in the Matrix, that's what I know Kung Fu.
I know Kung Fu,
but they have a cool, like, plugging in that interface is cool, and also even in that series they have like the mecha suits that they defend Zion with. A
lot of movies ended up. Yet the concept's been around.
Yeah, Alien and these type of things too. Like they have them.
No, good answer. Teleoperation or full autonomy? Which one is going to win this decade?
Operation or full autonomy? I think this decade is going to be teleoperation. Like full autonomy is, I think it's going to be shared autonomy. It's going to be, we're going to build slowly as we go from, ChatGPT 2 to 3 to 3.5 to 4 to 4.3 or whatever, 4.5. It's like we're going to build that up over time, but I think that it's going to require teleoperation, and it doesn't necessarily. It's going to come through a couple different data sources and ways.
Yeah, comprehensive answer there. Humanoid robots, inevitable or inevitable disappointment?
I would say inevitable. And I will say a little bit longer answer on this because I visited Shenzhen last year. I know this is the lady route. I'll be very quick. It's there's certain demographic things with like population declines, the replacement rate, and even in countries like China that have like report having billions of people, like 1.5 or 1.3 billion people, having the replacement rates are really like the birth rates are very small. And so like if they can build fleets of humanoids and maintain that ability to do a lot of the work, they're going to be able to, they built like this incredible manufacturing infrastructures in like Shenzhen and stuff, and they might be able to keep it rather than have to like send it off to kind of like emerging economies or stuff to make their goods.
Yeah, I think that's the right vision for the future. When we get there, that's nobody really knows. Is it 5 years or 30 years away? Somewhere in between, probably. Yeah. All right. So building on that, finish the sentence. The thing standing between robots and mass adoption is blank.
So that before workflows. Yeah. Kind of how do you use ChatGPT? You need a way to work with it, right?
Okay, and that's the area you're operating in, and that's what you're pushing. Next question: best demo you've ever seen that made you think, "Wow, we're actually doing this at Happily."
Best demo that I've ever seen that said we're actually doing this. Think of some like some of the robotics assembly. Okay, so what I'm going to say is I'm going to say something that is not hyping up Happily, but it's something that I looked at when I observed. I was super into was recently maybe I'll say something else out of Happily. So the demo that excited me the most that I've seen recently, I've seen two. One was I really love that the sharper robot hand, the dexterous hand manipulation, and it folding like this windmill, creasing it and doing this stuff. And they do a great job marketing. And I was at GTC recently and we were in the booth next to them and I got to see the hands live and they were great. And while I was at GTC, because now you get a lot more of these humanoids and things like this. So this was at the NVIDIA conference in I think it was March, was this company, Generalist Robotics. We were demoing with them inside of the Universal Robotics booth with Scale AI. And they had really cool egocentric kind of data capture and they were basically assembling the cell phone case and putting the cell phone in, and they were disrupting it at points anytime throughout the thing. And it was still, these Universal Robotics arms were still going in and folding and putting everything there. And so getting the data, being able to build this type of stuff, I'm starting to see like our devices being used in these teleoperation contexts. And when I see outputs like that, I go, oh my God, like this is, it's happening.
That was autonomously happening? Wow, that's pretty impressive. Now coming to Happily, the next question, you have so many products, like you were saying, the momentum was behind you. You're launching all of these in different areas. But if I'm an investor and I'm saying, here's $100 million, but you're only allowed to keep one of your products. You have to kill the rest. Which one survives?
If the investor says that I have to have $100 million in the near thing, I would say the inverse. But I love the Minverse for the legacy piece and where it can play. But the inverse and how it can be used to control robots and it's very fun to use and you can fly drones and you can pilot submarines and you can pilot humanoids and these things. It's very cool.
Got it. And are you shipping these with some software to demonstrate the use cases?
Yep. We have a thing called the Happily Hub, which has a bunch of different demo, basically a feature sandbox. So it'll have like different demo applications. But then we sell a software, we bundle a software for the robotics applications, which is called HARP. And so that's the Haptic Advanced Robotics Programming. platform. And the idea is it's just allows you to, you know how intuitive is called intuitive surgical because of that layer that it makes it easy to use. The idea is that we want to build that for non-surgical applications. So being able to connect to 30, 40 different types of robots we can already control. You can hop right in, building the abstractions to really easily, like, you don't have to be a robotics integrator. You can get in, kind of put the things together, start manipulating a scene, collecting data with cameras and stuff. I really like that.
Yeah. Well, thank you for sharing that. In one word, the future of human robot collaboration is blank.
Workflows.
It all comes
I
down
really
to
mean it.
workflows and
Really
UI and UX.
Yeah, workflows, UI, UX. Like, if we can, like, I will say, like, obviously there's limitations in hardware and maintainability and serviceability. Humans, we interact with the physical world, but we can self-heal, right? We have these crazy billions of years of evolution behind us, helping out in certain capacities. But that being said, the airplane's pretty cool. Cars are pretty cool with rolling wheels and things like this. Like, we can design lots of really cool things. There is kind of a funny piece, and this is maybe a little bit of an aside, but like, I remember I always found it funny, not funny, but interesting. It's like, I'm not a particularly religious guy, but I did read the Bible at one point just to understand what the hype was about.
The hype was about, yeah.
And the book of Genesis, obviously, there's portion, and at one point they talk about, God created man in his image and these things. And we're trying really hard to do the same. We'll have like robots a few thousand years from now being like talking about their creators and these things. And it kind of, you've heard like the simulation theory and these type of things that we're running on a loop or something like that. I find that stuff super interesting where, we're trying our hardest to create the thing that's like us, but different enough that, I don't know, it's evolution. So it's interesting.
Yeah, humanoid is an example of that. Even cars, airplanes, like you were saying, with iteratively built complexity, we're basically mimicking evolution, responding to the challenges that are coming up, solving one burden with another utility and building on that. That whole innovation cycle is leading to pretty complex machines. And I wonder where it's going to take us in another 100 years. We went from the horse carriage to a car in a few decades, right? And from car to where we are now, that's been an exponential shift.
Totally.
And now the Chat GPT moment for physical AI is not that far out.
And I could have a whole nother hour conversation with you about whether this is good or whether like it's like there's certain aspects of it that I find overwhelming, and even myself knowing all about what's going on and be working this every day, I get overwhelmed and I'm like, what the heck? Like, are we going too fast? Are we doing things? I can imagine it's scary for a lot of people.
Yeah. And, it's funny you mention it. I pull on that thread from all of the really smart people that I'm talking to. And the common theme that I've seen is everybody is super optimistic. So they're saying we are going to have a utopia-like future, given that we put a safety layer in place, given that we're able to combat some of those lower basic instincts that humans have, and we're able to create right regulation, and we're able to educate people, which like it's a very, I feel I want to be optimistic, but it could go either way, right? And maybe we talk about that on a next conversation.
Sure. Can I just tease 1 second of that is,
yeah.
I know, like, so this utopia that people are imagining, like, let's say, do you think it was utopia for like Roman senators or whatever with their like large number of slaves that would kind of do all the work and the labor? And I don't know if it's utopia, but I think that's maybe a little bit of a selling point or something like that. I think we're basically, like, the term robot literally comes from slave, right? It means it's an old Slavic word. So I think it's interesting that I don't know if we're going to create a utopia, but I would imagine that if labor and stuff like that becomes a type of thing that really, like, hard or unwanted labor becomes a type of thing that we can like kind of offload, then it might end up being that could be in some of those like societies, or being like They could be interesting. I should probably look into like kind of what it was like, and maybe that will inform my answers for the
Mhm.
next conversation.
And it's a philosophical discussion that I think our societies need to have in terms of what's the place of humans and place of regular people in our society and humanity if the thinking process and creativity is no longer the selling point, because ChatGPT, Claude is able to produce outputs that mimic or even exceed us. And then our labor output is no longer the main value proposition. Then what value do we hold? What kind of, are we going to create different class systems where you're going to have under leveraged people and these,
Totally.
yeah, billionaire class? Yeah, we need to figure that out, and that will ultimately determine which way we go: dystopia, utopia, somewhere in the middle, and will it be a constant battle? Yeah,
one of my favorite podcasts I've listened to recently talks about I think it might be a YouTube show, but it's a podcast. It talks about how like what we're seeing right now very closely emulates like what happened in the US in like the 1900s, like the East, which was like this, a lot of robber barons, these huge like Carnegie and Roosevelt and Vanderbilt, and these people, not Roosevelt, Rockefeller, I should say, these people that like had these huge monopolies, and then society was changing where industrial automation and factories and things like this, the steam engine and cars and all these things were coming out, and people were just totally blown away as well, right? So lots to discuss, and hopefully,
I've heard the same podcast. It's a lady that put a book out,
yeah,
and right, like I think that's who you're
yeah.
talking about.
The one I'm thinking of, I think I can't remember, to be honest, but I think it's a guy. But I'm sure there's a few.
Yeah, that parallel between the 90s and 20s, how you had that market defining and all these seismic shifts that took place then and are taking place now.
Mm-hmm. What's your favorite podcast outside of Robot Builders Club?
Well, I don't actually listen to Robot Builders Club. I produce it, and I don't think too many people do. But in terms of, I like Hassan Minhaj's
Cool.
and Trevor Noah's podcast. I think for me, I'm a big fan of Trevor Noah because he's such a worldly person and a deep thinker and a philosopher.
His book. I really liked his book, and it's also I agree, and I like Hassan Minhaj too. He was it the Daily Show that he got his kind of start on? Yeah, he was great.
What's your favorite podcast or
podcast? My favorite podcast, I listen to a lot of history podcasts. So one called Conflicted, I love. That's like I grew up in the Middle East. I think I told you last time I grew up in Saudi Arabia. So I remember one of my favorite podcasts I listened to recently was called the Prophet's Dilemma. And it was about the schism in Islam and all the interesting like, story behind that. So I like that. I like one called Extinct Zoo, which is about natural history and like all the evolution and animals and and also the earth, how the earth has had like, all these different changes and form factors that just like it's the same place, but totally different, right? Like I like learned recently that the Mediterranean at one point was like almost completely dry because it closed off, and these things that you just don't, would never make sense to, I would never,
Sahara was under the ocean and not under the ocean. It was a rainforest. Sorry.
Yeah. So I find this stuff super interesting, and
On the politics side, I like Ezra Klein. He's a columnist for I believe New York Times or.
He started, and he started off. I forgot what the name of the magazine or the thing, but I listened to Ezra Klein, and I listened to one called like The Rest Is History. Not The Rest Is Politics. But yeah,
very cool.
Cool.
Well, I've taken a lot of your time. I think I've loved this conversation.
Yeah,
and I don't say that to everybody. I think this was the best conversation I've had. And I think,
thank you.
I love this format because there's something special about like podcasts where you have this dedicated time, you're zoned in, it's almost meditative, and you're connecting, you're trying to understand, you're back and forth trying to get to know each other a little bit. So I've loved learning about Happily, the industry. Selfishly, like it's given me a better perspective of where robotics is headed, your viewpoint, your place in it, and the place of haptics on how it will be used for training, for robot control, for gaming, all of this massive opportunity where you're really ready to take advantage of. And your just views on different things and learning from you, from history to the Canadian politics to looking back at Silicon Valley from your eyes. So it's
I've
been
got a
wonderful.
funny YouTube algorithm.
Yeah. Yeah. We will turn this into
I'm sure we
multiple
would have
different.
similar things. No,
Yeah.
likewise. I've really enjoyed. Thank you for giving me the opportunity to chat. It's always fun to be able to. It makes you think also about some of express your own ideas and try and think about them clearly. Like some of the questions, you're like, oh, those are some of the questions around even the philosophical side of trying to describe the motion, trying to basically the way we were presenting certain things, like very using prose and things like this. I think it's interesting to look at that. And obviously there's probably certain things that are implicitly baked into the way that we present things that I don't even do explicitly or intentionally. Right. And it's interesting to think about that stuff. So I appreciate having the ability to reflect, and hopefully when I'm in San Francisco or the Bay next time, I can connect. Yeah.
Reach out. Let me take you out for dinner.
Oh, I love that.
You're sending me a red mini verse. Let me return the favor.
I'll hand deliver it over our 2 Michelin star restaurant, right? So
I love it. Pleasure's been all mine, sir.
Thanks,
thank you so much. Let's stay in touch, and I hope to see you in person.
Likewise. Thank you. Bye.
Yeah. Thank you.